Welcome back. I'm playing around with something called tracing as a weekend project just to have some fun. I take a break. I know taking a break and doing more work is kind of a meme here, but there we go. Anyway, I was reading at distributed tracing instrumentation on the Microsoft.NET documentation, and it talks about tracing. So tracing is the third component of common sort of diagnostic tooling that people do for services. First being logs, obviously. The second being metrics, which we talked a lot about with the asset worker before. And then the third being tracing. So this is tracing. So what is tracing? Tracing lets you take a look. Oh, that's the wrong tracing one. You want this one. Nope, you want this one. Lets you take a look at any failures, successes that happen across your infrastructure, and to figure out, hey, what's going on, what's happening. So I've hooked that up to my local copy of the standalone worker, and then I've got this tool, which is Jaeger, which can read traces and sort of render them on screen for you, running in a Docker container. And so we can take a look at how the asset worker is doing. So if we go ahead and take a look at this one here, we can now see the path or the process that the asset worker took to complete this particular initiative, which was one task. And we can drill in and kind of see details about it. So we can instantly see that this one has failed because of the exclamation mark here. But why did it fail? Let's expand this and we can take a look. And we can see, hey, it was a BC1 image and it errored out. Yep. Let's take a look at the logs and we can see, ooh, an exception. We can expand that. And there's our stack trace right there. Unsupported export format R8. And there you go. That is why this task failed. All this other stuff is just sort of showing, like, you know, what else is going on. Of an interesting note here, we've also got information on HTTP requests that we're doing. So whenever we do something to the actual API, we can see that in here by expanding that. So this is us probably extending the computation time, just something the asset work has to do very regularly. And it's saying, like, hey, here's everything that's going on. Now you can expand these tags and you'll see like more information there, but I don't really want to, you know, because that gets too much into sort of the individual image. I don't want to do that. We can go back and we can take a look and see everything that's happening. On the top here, we've also got timings. The reason why there's such a big gap between these is just like changes in when I'm running the local worker and not running the local worker, because I'm instrumenting the asset worker with tracing as we speak. But they think the circle is like how long stuff took. What we can do here is if we swap to longest first, we can see, hey, this task took 22.5 seconds to run. Why? Sounds like a lot. What happened? So we can see that it was generating variance for that entire time, and then it failed up here, and here's the exception. Array dimensions exceeded supported range, out of memory exception. Fantastic. So we can go ahead and take a look and figure out what's going on there. This looks to be an image. Raw RGB image. Again, I won't expand the big tags because that gets too close to the actual original image. That's tracing for you. The power of tracing, however, actually comes when you start doing it across different services. So the way that this all works is that different services, say like your HTTP service, your worker service, could implement tracing, and then they can send all the information to one place, like Jaeger or other tools that can read it. And what that allows you to do is track the same operation across like an entire like fleet of services. So let's say that your customer orders one item and they add that to their cart. That might involve like 4 or 5 services, and you can take a look at the exact flows through there. To illustrate that, I've got no, wait, that's another one. Where are we here? This is Jaeger's demo instance of Jaeger, and you can see what's going on here. They've got a little API set up that errors out, and you can see that it goes across multiple services here. The word front end here is the service, and so you can see that we go off to MySQL, and we can expand this so we can see, hey, what happened? Oh, look, here's the exact SQL query that was running. I don't know if that's visible, but there we go. I don't quite know what the black line means, but I'll look into that at some point. A segment on the critical path. Oh, okay. We'll take a look at what's going on. You can also see HTTP, stuff like that. Actually, we don't need to because this is a demo installation. I wanted to figure out what that means. Okay. So that's tracing for you. I've also looked into this tool, Sec, Sec. It will do tracing and logging all in one, and it can be useful to sort of have next to your app when you're sort of diagnosing it. So again, here you can see like orders and stuff like that. Lots of people use this apparently. Sec also allows you to do alerting on that, but it's also beneficial to note that all of this stuff works with a standard called OpenTelemetry. OpenTelemetry is a sort of suite of tools, utilities, schematics, schemas, APIs, SDKs that are designed to sort of become like an octopus merger of telemetry from wherever you need it, like containers, network services, databases, whatever the hell you need. It could go into OpenTelemetry and then all come out the same side and all be sort of collated together like I showed you in that demo. OpenTelemetry supports a bunch of languages. It's like even PHP. So if you've got services written in different languages, they can talk to each other as well. This all started when I wanted to go ahead and just read random documentation on my weekend. I read this sort of like at the beginning of the day, and I'm like, that's cool. I'll pot around with that for a little bit. And now it's done. It uses the system.diagnostics.activity classes, which are kind of like everywhere. They've a really old API that OpenTelemetry just sort of passes into. You can see here you make a source, and then you make an activity. So the activity is what you see in over in here. Each of these is an activity. And that's the important distinction between this and, say, more traditional CPU profiling. Because in more traditional like CPU profiling of an application, you would just see like function names and raw data. But what this allows you to do is it allows you to say, hey, this is what it means like in human language. Here's exactly what's going on. And then, of course, you can then augment that with data that is more structured, but it's up to you, really. I am just playing on this. I wanted to figure out why a couple of tasks were failing, and it was difficult for me to sort of see how long they were taking and what was going on. So this allows me to do it well. We've got logs for the service, of course, but like sometimes logs are just like a mess, whereas these are like really structured. You can drill into them, very interactive. Hope you found this interesting. Speak to you soon.